Hi, in this video I am going to discuss about BCD addition and subtraction. First let's see about BCD code, or otherwise we can call 8421 code. BCD code is an abbreviation of binary coded decimal. That is a coding scheme relating decimal and binary numbers. And this BCD is a type of binary code is used to represent a given decimal number in an equivalent binary form. The BCD equivalent of a decimal number is returned by replacing each decimal digit in an integer and fractional parts with its 4-bit binary equivalent. In general, BCD codes are also called 8421 code. This is because 8, 4, 2 and 1 are the weight of the 4 bits of the BCD code. Next, BCD code. How we can represent the BCD code? In this code, decimal digits 0 to 9 are represented by their binary equivalents using 4 bits individually. For example, the decimal number 429 is expressed in BCD form. Each decimal number is represented by equivalent 4-bit binary number. So 9 is represented by 1004 and 2 is represented by 0010 and 4 is represented by 0100. So the lowest BCD digit is 0 and the highest BCD digit is 9. So this is the truth table for decimal digit and the BCD equivalent. So the 0 to 9 combinations are used for the BCD code. So in this BCD code, 10 to 15, the total 6 combinations are there. This 10 to 15 combinations are the invalid code. This is the example for decimal to BCD conversions. The first example, the decimal number is 589 and we are converting into BCD code. For 5 the BCD code is 0101 and for 8 the BCD code is 1000 and 9 the BCD code is 1001. Second example, 6927. We are converting into equivalent BCD code is 6 is 0110 and 9 is 1001 and 2 is 0010 and the 7 is 0111. BCD is a numerical code and it can be used for arithmetic operations. Now let's see how to add two BCD numbers. The first condition is add the two BCD numbers using the rules for basic binary additions. Then if a 4-bit sum is equal to or less than 9, then it is a valid BCD number. Suppose if your 4-bit sum is greater than 9 or if a carry out of the 4-bit group is generated, then it is an invalid result. Then in this condition, we have to add 6 to a 4-bit sum in order to skip the 6 invalid states and return the code to 8421. Then if a carry results when 6 is added, simply add the carry to the next 4-bit group. These are the procedures to perform the BCD addition. Now let's see the examples. The decimal numbers are 113 and 101. The answer is 214. So now let's see how we can perform in BCD. So first we are converting the decimal number into equivalent 4-bit form. So 1 is 001 and 3 is 0011. Then 101 is 001 and 000 and 001. Now we are adding by using normal binary rules. So 1 plus 1 is 0, then the carry presents. So again 1 plus 1 is 0, then carry present here. So the answer is 0100. Then here we are adding 1 plus 0 is 1, the remaining 3 zeros. Next 1 plus 1 is 0, sum 0, carry 1. Carry is added to the next bit. So that is written here. So the final answer at this stage is 214. So it's all the digits are coming under less than 9. So it's a valid BCD number. In this example, 7 plus 9 is equal to 16. Now let's see in binary form. So 7 is equal to 0, 1, 1, 1. 9 is equal to 1, 0, 0, 1. Now let's see 1 plus 1 is equal to 0. Then the carry is present. We are added the carry here. So 1 plus 1 is 0 again. Now again carry present, we are adding with this point. So 1 plus 1 is 0. Then again carry presents, we are adding here. So now 1 plus 1 is 1, 0. Sum is 0, carry is 1. So now carry is present, then we have to add 6 to make it into a valid BCD number. So we are adding 6 to the result. So 0, 1, 1, 0 is 6. Now 0, 1, 1, 0, 1, 0, 0. Now we are writing into 4-bit form. So this is 1 and this is 6. So answer is 16. It's a valid BCD number. Now 8 plus 9. 8 plus 9 is 17. Now let's see in BCD 100 and 100. So we are adding these to 1. 0 plus 1 1. 0 0 1 plus 1 is 0. So carry presence. When the carry is present, it's an invalid number. So to bring it back into a valid BCD number, we are adding plus 6. So when we are adding plus 6, 1 plus 0 is equal to 1. 0 plus 1 is 1. 0 plus 1 is 1, 0, 0. Then 1, 0, 0. So the answer is 1, 7. That is 17. It's a corrected BCD value. In this example, 147 and 380 in decimal form, the answer is 527. Then let's see. First we are converting into binary form. Then we are adding the values. So BCD code of 147 and this is the BCD code of 380. Now we are adding these two starting at this point. 1 plus 0 is 1. Again 1 plus 0 1. 1 plus 0 1. Now 0 0 0. Next is 0 0 0. 0 plus 1 1. 0 plus 1 1. Now 1 plus 1 plus 1 is 0. Now carry is present. So 1 plus 1 is 0. Again carry is present. It's added with the next higher order bit. So 1 plus 0 is 0. It's equal to 1 0. So now if you are looking into the result, this is 7. So it's a valid sum. This is 1100. That is 12. So it's an invalid BCD code. Next it's 0100. It's a valid number. So the invalid BCD combination is this one. So we are adding 6 to these combinations to bring back into valid BCD code. So 0 1 1 we are writing, then we are adding 6 to this combinations only. So 0 plus 0 0, 0 plus 1 1, 1 plus 1 1 0, sum written here and carry added here. Now 1 plus 1 is 0, sum here, carry is added to the next bit. So 1 here, now 0 1 0. So now this is equal to 101 is 5, 0010 is 2 and 011 is 7. All the bits are coming within 9. So it is a valid BCD number code. In this case, 92 plus 58 is equal to 150. Now let's perform in the BCD. Now write it in BCD form for 92 and 58. So this is 9 in BCD and this is 2 in BCD. And this is 5 in BCD and this is 8 in BCD. Now we will start to add the numbers from the LSB. 0 plus 0 is 0, 1 plus 0 1. 0 plus 0 is 0, 0 plus 1 is 1. Now in this point 1 plus 1 is 0, sum 0, carry 1. Carry is added to this bit, so it's 1. Now 0 plus 1 is 1 and 1 plus 0 is 1. Now let's see this combination. This is 14. 14, decimal 14, and this is 10. So both combinations are greater than 9. So we are adding plus 6 to both the combinations. So now we are adding plus 6 to this combination and plus 2 with this combination also. Now let's see. 0 plus 0 is 0, 1 plus 1 is 0, and carry is added to this bit. So 1 plus 1 is 0. Now this again carry is added to this bit. So 1 plus 1 is 0, carry is added to this bit. So 1 here. Now 1 plus 1 is 0, again the carry present, carry is added here. So triple ones are present here. So 1 triple 1 is equal to 1, and the sum is 1, carry is 1. So carry is added to here. So 1 plus 0 is sum here. So 1 plus 1, that is carry from the lower order bits. Now sum here and carry here. Now we are writing in BCD form. It's equal to 1, and this is equal to 5, and this is equal to 0. This is 150 in BCD. So it's a valid BCD number. Now in this combinations, first let's see in decimal 385 and 118. The answer is 503. Now let's check in BCD form. First write it in BCD form for 385 and 118. Now let's start the addition from this point. So 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1. Now 0 plus 1 is 1, 0 plus 0 0, 0 plus 0 0, 1 plus 0 is 1. Now 1 plus 1 is 0, and the carry present added with the next bit. So 1 plus 1 is 0, again carry present added with this bit. So 1 0. Now looking into this point, this is 4, this is 9, both are valid BCD. This is 11, so invalid BCD. So we are adding 6 to this combination. So 1 plus 0 1, 0 plus 1 1, 1 plus 1 1 0. So sum 0, carry here. So carry is added with this bit. So again 1 0. So sum here, carry is 1 here. So again added with this point. 1 plus 1 is 0. So it's added with this bit carry. So 1 here. So next is 0 1. So these bits are written as it is. Now in this value, only this combination is invalid. That is, it is decimal 10. So we are again adding 6 to this combinations. So 0 0 1 1 is written here. So here we are adding these two bits. 0 plus 0 0. 1 plus 1 1 0, carry is coming. So again carry added with this bits. 1 plus 1 0, then carry present. So 1 plus 1 is 0, and carry is added with this bit. So 0 plus 1 1 and 0 1 0. Now all the combinations are valid number. So the result is 503. It's a valid BCD code. Now let's see 191 and 171. It's equal to 362. Now let's start with this point. 1 plus 1 is 0, sum 0, carry 1, carry is added here. So 1. And now 0 plus 0 is 0, 0, 0. Next 1 plus 1 is 1 0. Sum is here, carry 1, carry is added to the next higher order bit. So 1 plus 1 is 0. Then again carry is added here. So 1 plus 1 is 0. Again carry presence. So 1 plus 1 is 0. Again carry present here, including carry. It's triple 1. So triple 1 is equal to 1 1. Sum carry 1 carry. Sum is carry. Sum is equal to 1 and carry is also equal to 1. So here 1 and this carry is forwarded here. So carry is 1. So 0 0. Now all the combinations are within BCD, but still it's an invalid number because the carry is propagated to this bit to this bit. So carry is present at this point. So we are adding plus 6 to this middle combinations. So we are adding plus 6 to this combinations. So when we are adding plus 6, the outputs are 3, 6, 2. It's a valid BCD. In this case, same way 6 plus 3 is 9. We are adding from this point. 0 plus 1 is 1, 1 plus 1 is 0, carry is present, carry is added with this point. 1 plus 1 is 0 and carry present, 0 plus 1 is 1. So this is 1001, it's a valid BCD. Now 25 plus 13 is equal to 38. Now let's see. First we are writing equivalent BCD form. 1 plus 1 is 0. Again carry present. 1 plus 1 is 0. Carry present. 1 plus 1 is 0. Again carry present. We are writing the carry here. Now 1. Next 0 plus 1 is 1. So 0, 0, 1, 1, 1, 0, 0. Its answer is 38. It's a valid BCD. 58 plus 37. Same way we are starting from the addition here. 0 plus 1, 1, 0 plus 1, 1, 0 plus 1, 1, 1 plus 0, 1, and 1 plus 1 is 0. Carry is present, carry is added with this bit, so 1 plus 1 is 0. Again carry is added with this bit, so 1 plus 1 is 0 and carry is added with this. So now this is 8 and this is 15, so it's a invalid combinations. We are adding 6 here, so 0 plus 1, 1, 1 plus 1, 0, remaining 1. So triple 1 since 1, 1. So sum 1 and carry is added with this bit. So sum is 1 plus 1 again 0. Sum is 0. Carry is added to this bits 1. And remaining 3 bits are as it is 1, 0, 0. So now both the bits are valid BCD. And the answer is 9 and 5. 9, 5. BCD subtractions. BCD subtraction can perform either by 9's complement method or 10's complement method. First, let's see the example. Example for BCD subtraction to obtain 9's complement method. First, let's use direct method. Minus is 893 and subtrahend is 478. With the direct subtraction, the answer is 415. Now let's see BCD subtraction by 9's complement method. First we have to take the 9's complement of the subtrahend. That is first 9's complement of 478 is obtained by subtracting 478 from 999. So while subtracting we will get the answer 521. Now we are adding this 521 with the minor. So now minor is 893 and 9's complement of the subtrahend is 521. Now we are adding this one. Now carry, we are getting the carry. In this 9's complement method we have to add the final carry. So we will get the answer is 415. Now we are performing subtraction by subtraction in BCD form by 9's complement method. So our inputs are 893 minus 478. So first we are finding the 9's complement of 478. The 9's complement of 478 is 521. Now we are adding these two. So first minor is 893 and the 9's complement of subtrahend is 523. Now we are writing in BCD form. That is each bit is represented by 4 bit forms. Now we are adding these two combinations. So 1 plus 1 is 0. 1 plus 1 is 0. Now sorry. We are starting from this point. 1 plus 1 is 0. Then carry is present. So 1 plus 1 is 0. Now carry is added with this bit. So answer is 1. Now 0 plus 0 is 0. Now this point 1 plus 0 is 1 and 0 plus 1 is 1 and 0 plus 0 is 0 and 1 plus 0 is 1. Now 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1. Now we are checking all these combinations are valid BCD or not. Now 0, 1, 0, 0 is 4, it's a valid BCD. Now this 1011 is 11. It's greater than 9. So it's an invalid BCD. Similarly 1101 is 13. It's also invalid BCD. So we are adding plus 6 to these combinations to bring back into valid BCD form. So we are adding 6 here. So 0 1 0 0 writing as it is. Now 1 0 adding 1 plus 0. 1 1 1 plus 1 is 0, sum 0, carry is added here, so 1 plus 1 is 0 here, again carry present, so 1 plus 1 is 0, again carry is present, we are adding here, so 1 plus 1 is 0, again carry we are adding here, 0 plus 1 is, sorry, 1 plus 1 is 0. Now again 1 carry is present here, so triple ones, so sum 1, again carry present, so 1 1 is 0 and 1 and 1. In this one, end around carry, we have to add with the LSB bit. So this first bit becomes 0 1 0 1. So now equivalent BCD form is this is 4, this is 1 and this is 5. So it's a valid BCD form. In this example, 79 minus 26 is 53. Now it's a direct subtraction. Now let's see BCD subtraction. For BCD subtraction, we have to take 9's complement of subtraction. The subtrahend is minus 26. So we are subtracting 99 minus 26. So it's equal to 73. Now we are writing 79 in BCD form and 73 in BCD form. Now we are start to add from this position. So 1 plus 1 is 0. 0 plus 1 is 1 plus 1 is 0 and the carry is present, carry is added with this point. So 1 plus 1 is 0, again carry present, carry is added here, so here 1. Now 1 plus 0 is 1. Next 1 plus 1 is 0, carry present, so triple 1, so sum 1, carry 1, so again triple 1, sum 1, carry 1. So now these both the combinations are invalid. This is 12, this is 14. So we are adding plus 6 to both the sides. So 0 plus 0 0, 0 plus 1 1, 1 plus 1 0, carry present. So 1 is added here, 1 plus 1 0, again carry present. We are adding with this position, so 0 plus 0 is 1. And next 1 plus 1 is 0, now carry present, so triple 1, sum 1, carry 1, carry is added with this position, so 1 plus 1 is 0. Next carry is also present. This is an end around carry, so the end around carry is added with this LSB bit. Then our final answer is 5 3. It's a valid BCD. Now in this example, 89 minus 54 is 35. It's direct subtraction. Now let's see BCD subtractions. BCD subtraction, first we are finding the 9's complement of subtraction 54. So 99 minus 54 is 45. Now we are writing 89 in BCD form and 45 in BCD form. Then let's start with this position. So 1 plus 1 is 0. Carry is present. So here 1. Now 0 plus 1 is 1. 1 plus 0 is 1. Next is 0 plus 0 0. 0 plus 0 0. 0 plus 1 1. 1 plus 0 1. Now both the combinations are invalid. This is 12 and this is 14. It exits 9. Then we are adding plus 6 to both the combinations. So again we are start to add this position. So 0 plus 0 0. 1 plus 1 0. Again 1. So triple ones are present at this position. So triple ones equal to sum 1, carry 1, carry is added with this position. So 1 plus 1 is 0. Again carry present, carry is added with this point. So 1 here. Now 0 plus 1 1 and 1 plus 1 is sum 0, carry is present, so carry is added with this position. So 1 plus 1 0, so sum 0, carry 1. So end around carry is present, end around carry is added with this position. So the final answer is 3 5. It's a valid BCD. The given question is 679.6 minus 885.9. So here minus is smaller, subtrahend is bigger. Okay. So first we are taking 9's complement of subtrahend. So 999.9 minus 885.9. So the answer is 114. Now we are writing in the BCD form. First we are writing subtrahend 679.6, then 9's complement of subtrahend, and this is the minute. Now we are starting to add this point. So 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1 and 0 plus 0 is 0. Next to this position, 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 1 is 1 and 1 plus 0 is 1. Next to this point, 1 plus 1 is 0, then 1, 1 with the carry. 1 plus 1 is 0. Again carry is added with this point, so 1 plus 1 is 0 and the carry is here. Next is 0 plus 1 1 and 1 plus 0 1, 1 plus 0 1 and 0 plus 0 0. Now in this combination is greater than 9. This is 13. So we are adding 6 to this combination. So writing this bit as it is and starting the addition from this point. 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0 and the carry is here. So 1 plus 1 is 0, again carry present here. So we are placing the carry here and remaining bits are as it is. So it is all the bits are valid BCD. Here no carry. Here in this case minus is smaller case. So in this final answer again we have to take 9's complement of 793.6 with negative sign. This is the final answer, minus 206.3. So when the minus is smaller case, we have to take the 9's complement of the answer again with negative sign. Now let's discuss BCD subtraction by 10's complement method. So the question is 768 minus 274 with a direct method. The answer is 494. So first see about 10's complement of subtraction. So 10's complement of subtraction, first we are finding 9's complement. 9's complement, then we are adding plus 1 to the 9's complement. Answer it's 726. So it's normal decimal subtraction. So we are adding 768 plus 10's complement of 726. The answer is 494. Here in this 10's complement method we have to ignore carry. Here first we are writing the minus and subtraction in this BCD form. Then we are starting the addition from this position. So 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 1 is 1 and 1 plus 0 is 1. Then this combination 0 plus 0 is 0, 1 plus 1 is sum 0, carry is 1. So 1 plus 1 is 0, sum 0, again carry is present here, so carry is coming here. Next 1 plus 1 is 0, carry coming, so 3 ones, so sum 1, carry 1. So the carry is added with this position, so again 3 ones, so sum 1, carry 1, carry is presented here. Now this bit is 14 and this bit is 14, both are invalid. So we are adding plus 6 to both these combinations. So here we are adding 6 here. So see 0 plus 0 is 0, 1 plus 1 is 0, carry is added to the third bit. So now 3 ones, so sum 1, carry is added with this higher order bit. So 1 plus 1 is 0, the carry is forwarded to this position. So 1, we are placing 1 here. Next 0 0 0 1, writing as it is. Next again starting the addition this point. 0 plus 0 is 0, 1 plus 1 is 0, carry is forwarded this position, so triple ones, so sum 1, carry 1, carry is again added with this point. So 1 plus 1 is sum 0, carry is 1. We have to ignore carry in this 10's complement method. So now the answer is 494. It's a valid BCD. In this question, 897 minus 768, it's equal to 129. First, we will take 10's complement of subtraction. So first we will take 9's complement of 768, it's equal to 231. Then we are adding plus 1 to this one, that is a 10's complement of subtraction. So 232 is an 10's complement of 768. Now we are writing minus and subtraction in BCD form. Then let's start the addition from this point. So 1 plus 0 is 1. 1 plus 1 is 0. Now this one is again added with this point. So 1 plus 1 is 0 and carry 1 is presented here. Next 1 plus 1 is 0 and carry is added with this point. So 1 plus 1 is 0. Again carry presented. So 1 here. Next 1 plus 0 is 1. Now 0 plus 0 is 0. 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1. Now this is 10 and this is 12. These two are invalid combination. So we are adding 6 6 to this combination. So we are writing 1001 as it is. Then we are starting the addition from this point. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 0. Then we are adding with this point, that is carry is added with this point. So 1 plus 1 is 0, then 1 is carry is forwarded here. So 1 writing here. Then 1 plus 1 is 0, again carry. So 1 plus 1 is 0, again carry. So 1 plus 1 is 0, the carry is presented here. In this tens complement method, we have to ignore the carry. So the final answer is 129. In this question, 130 minus 245, the answer is minus 115. In this case, minus is smaller. So first we will take 9's complement of subtraction. So first 999 minus 245, it's equal to 754 plus 1, that is 755. It's a 10's complement of subtraction. Now we are writing minus and subtraction in 10's complement form. Then start the addition from this position. So 0 plus 1 is equal to 1. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 0 is 0. Next 1 plus 1 is 0. Then carry is added here. So 1 plus 1 is 0. Again carry present. 1 plus 1 is 0. Carry is present here. Next 1 plus 1 is 0. Again carry present. 1 plus 1 is 0. The carry is added with this point. So 1 plus 1 is 0. Then carry is presented here. So the answer is 8, 8, 5. But in this case, minus is smaller. So we have to take 9's complement of 885 with a negative sign. 10's complement of 885 with a negative sign. So the answer is minus 115. Thank you.